In the last video, we went through a kind of a long proof showing that if you have a parallelogram, the opposite sides of that parallelogram have to be congruent. It's not just the lines, the sides are parallel, they're also congruent to each other. So one of those was part of the definition, and the other was a consequence of that definition. So that's kind of cool. Another thing that we want to do is we want to show things about the angles of a parallelogram. And I just wanted to quickly switch over and show you what I have written in my quadrilateral reference sheet. So this is kind of what I wrote for the definition section. And so here's what we're going to use for the rest of the proof. So facts about parallelograms. We know the opposite sides are congruent. That's what we just saw in the last video. In this video, we're going to talk about how the opposite angles are congruent and about how the consecutive angles are supplementary to each other. Remember, the consecutive angles are just as you're going around from one angle to the next one, as you're kind of tracing your way across the parallelogram. Consecutive angles are the ones that are kind of next to each other, if you know what I mean. The last statement we have here is diagonals bisect each other, and I'm going to have you read over a proof for this for homework. And then we'll talk about the bottom half of this in the next video. So what we're going to do here is we're going to show that the opposite sides are congruent and the consecutive angles, opposite angles are congruent, consecutive angles are supplementary. But rather than doing a formal proof, we'll just kind of think about what we've been talking about with parallel sides and then kind of just convince ourselves that it's true. All right, so here's a parallelogram that I drew in bold, and just using dotted lines, I sketched out these two parallel lines and this transversal. Okay, so we've got a lot of different facts that we know about these triangles. The angles that are formed by these lines. The first thing I know is that this angle right here, I'm going to call this X, that this is congruent to this angle X up here. Do you remember the name of the relationship between these two angles? If you said that they were alternate interior angles, you're not quite right, because remember, alternate interior angles are the mark of Zorro. And this isn't there, between this angle and this angle, there isn't a Z shape there. So these aren't alternate interior angles. They're not, first of all, they're not on different sides of the transversal. And second of all, this one is inside the two lines and this one is outside the two lines. So it's not alternate, it's not interior. They are angles though. Do you remember what those are called? That's the other major one. Those are called corresponding angles. So it's like this is the northeast corner of this intersection, and this is the northeast corner of this intersection. And since all of these roads are parallel to each other, well, these two roads are parallel to each other, these two have got to be the same size. Okay, so those are corresponding angles. And I also know if I've got angle X and angle Y here, what's the relationship between these two angles? Well, they're adjacent angles because they've got the same vertex and they're next to each other. We don't have one inside the other, and they've got this one side in common to the two of them. What would happen if we measured those two angles and then added them together? What would that sum be? Well, if we added these two angles together, we'd get a straight line. So that would be 180 degrees. So X and X are congruent. Well, why don't I call this X prime? X and X prime are congruent. They're the same size. X and Y they add up to a straight line, so that makes them supplementary angles. So X and Y are supplementary angles. So does it make sense that these two angles also have to be supplementary? Well, it does, because saying that X and Y is supplementary means that X plus Y is equal to 180 degrees, but we know that X is equal to X prime. So therefore, It just stands to reason that x prime plus y is equal to 180 degrees. And so these two angles have to be supplementary to each other. But these are the consecutive angles of this parallelogram. So what we just showed is that the consecutive angles of a parallelogram are supplementary. They add up to 180 degrees. Okay, so that was pretty cool. Let's see if we can convince ourselves of the other fact, that opposite angles, that this angle has got to be the same as this angle, and this angle has to be the same as this angle. Well, to do that, why don't we tilt this diagram on its side a little bit? We were taking advantage of the last part in the fact that these two sides are parallel to each other. Now let's take a look at the fact that these two sides are parallel to each other. And now this is our transversal, cutting it. So we've got x prime. So I've got x double prime here. Once again, these are corresponding angles. And these y prime, and these are consecutive angles of the parallelogram. So we know that x prime plus y is equal to 180 degrees because they're consecutive angles in this parallelogram. We know that x prime and y prime, let me write y prime here so that it's facing up. We also know that x prime plus y prime is equal to 180. So is it obvious looking at this that y is equal to y prime? Yeah, it really is, because y here, if we solve that, that would be 180 minus x prime, and y prime, solving this, is 180 minus x prime. So y and y prime are both the same thing. Okay, so what we just showed is that that angle and this angle have to be the same size because they're both supplementary to this guy over here. Okay, so rather than doing a formal proof, what we just kind of did is went through and argued to ourselves that the consecutive angles of any parallelogram are supplementary. So these two guys are supplementary. These two guys are supplementary, which means that the two angles on opposite sides of the parallelogram have to be congruent to each other. All right, so these are facts that we're going to be able to take advantage of if we ever get problems that use numbers. As long as we know that a figure is a parallelogram, we're going to be able to do all kinds of math with the figures in them, with the angles and the side measures, knowing these key facts about parallelograms.